Okay. Right now we'll start with direct variation. And direct variation is just that this is how it goes. The formula is y equals kx. Now, for direct variation to exist, there must be a direct relationship between the two things that you're talking about. Now, they must be also directly proportional, which would make them good for direct variation. And then this is just basically a tool that you can use in algebra to solve many problems, even in the real world. Now, first of all, for direct variation, since the equation is y equals kx, k is actually the constant of variation, and k would not equal 0. So, right now, in order for us to understand direct variation, we would have to translate word problems into the formula. So, wages earned varies directly with the number of hours worked. For this, it would be W, wages, equals the constant of the variation, times number of hours worked, H. So if they ever give us any values for wages earned or any values for hours worked, we'd be able to find the real world problem. Now, secondly, we can also translate another one. Circumference varies directly with diameter. Okay, so for this one, then we put C equals the Y up here was the wages. So C over here would equal varies directly with KD. So once we translate these, we would be able to solve it. And so for the next thing that we do, it would be, this is the next problem that we will get. The weight of an astronaut on the surface of Mars varies directly with her weight on Earth. A woman weighing 120 pounds on Earth weighs only 45.6 pounds on Mars. How much would a 135-pound astronaut weigh on Mars? So this is almost a real-world application, if you consider it. And what we know is varies directly. So the weight varies directly with the weight on Mars varies directly with the weight on Earth. So from this we will translate first. M equals KE. And then we will get 45.6 pounds on Mars. It's being plugged in down here equals K times 120. Now we got these numbers from the problem because 120 on Earth, 45 pounds on Mars. And then we're going to find the constant of the variation. So if we find the constant of the variation, we'll be able to take that constant and use it in this problem to solve the question. So for k, the constant, we get k equals 0.38, correct? So from this we can say that m equals ke. And since we have 135 pounds on Mars, it would be, this would go to m equals 0.38 e times e basically equals 0.38 we have 135 pound on Earth. She's weighing on Earth now, but we're looking for Mars. So Mars would be the X in this situation, the problem that we're trying to figure out. So we can times 0.38 by 135. And then we get 51.3 as m equals. So in other words, on Mars she would weigh 51.3 pounds. Now, these are very straightforward questions. These ones where you just translate and then you solve for k. And once you get k, you plug in back to the formula in order to get any side that you need. Now, because it's directly proportional, I am able to create a proportion. If I have a question that says y equals 0.6 and x equals 24, x equals 500, and then I have y equals question mark, I can set up a proportion to solve this. In other words, 24 over 0.6 is equal to 500 over x. And then we get x equals 12.5. So basically I should have used y here, but it doesn't really matter because I can just change that to y, and then I'll say y equals 12.5. So that's another way to solve. That's if they ever give you a table or so. And then we get another one. This one's a bit abstract and a bit different because it has approximations. The thickness of a paperback book, varies directly as the number of pages. A book 3.2 centimeters has 750 pages. Approximate the thickness, which would have 957 pages. So for this, the first thing that we're going to do is translate this into a equation. So the thickness of the paperback book, the thickness varies directly as the number of pages. So I can just use the pages. So T equals KP. 3.2, as I'm plugging in, because 3.2 cm thickness, that's the thickness. 3.2 cm is thickness over here, equals K, because I don't know the constant of the variation yet, is 750. So 750 pages goes to here. And then I find that K equals, by dividing 3.2 over 750. And then I got K equals 0.0042667. Now, for this, I would just use the calculator and take the answer that I got for K and then keep it later on because they're asking me to approximate the next thickness. So I'm finding the thickness now. So it would be xk times the pages. So it would be basically over here. If I'm going over here, I would take x equals and the answer that I got before for the k, 957. So both these times each other will give me the thickness. So I approximate, and I get x is about 4.1 centimeters. And that's basically all you need to know for direct variation, is to translate the formula into y equals kx form. And then from there you can find k and then plug in k to solve your problem. If you have any questions, just ask.